So welcome, everyone. Thanks so much for being here. My name is Gabe McPhail. I serve as one of the regional coordinators in Region 1 of the Community Resilience Partnership, and I work collaboratively with Abby Sherwin and Karina Grader from the Southern Maine Planning and Development Commission, Sarah Mills-Knapp from Greater Portland Council of Governments, Emily Rabbe, and Laura Graziano from Lincoln County Regional Planning Commission. And altogether, we serve as your regional coordinators for Region 1. We are R1CC, the Region 1 Coordinator Collaborative, and we're supported by several nonprofits, other regional planning organizations who serve as our advisory partners and provide technical assistance and support to all of our Region 1 communities, especially those enrolled in the CRP. And many of our partners are on the call today. So welcome to them. Thanks, everyone. This is our fifth our fifth one in our series of Building Stronger Communities in Practice, which builds off of the Building Stronger Communities online learning opportunities that we offered in the fall of 2022 and through May of last year. And we'll share a link in the chat to all of the recordings from those learning opportunities that we've had so far. The workshop topics we are offering in this In Practice series are primarily focused on funding opportunities and are really based on things that you've let us know you want to learn more about. The workshops are primarily designed for Region 1 communities enrolled in the Community Resilience Partnership, and we really hope that they'll provide you with an opportunity to get some technical assistance to connect and learn from other communities in our region as well. So today's workshop is kind of less of a workshop and really trying to be more of a conversation. A lot of you have shared with us, and as assistance providers and community members ourselves, we've experienced some of the challenges that communities have when we are transitioning off of fossil fuels to electric, especially when this work is related to setting and meeting emissions targets and meeting cost saving and efficiency goals. So we find that it's not always easy to address concerns about grid capacity and grid resilience. And a lot of different questions arise, not just for planners and community leaders, but also community members. So we've been compiling the questions that we're hearing from all of you as you work on addressing municipal electrification goals. And today we really hope we can begin to answer some of those questions. So this is our first in a series of 3 grid conversations about the regional electric grid. The next conversation we'll be holding next Tuesday, January 30th. That will be with the Governor's Energy Office. And then in February or March, we're hoping to host a workshop that will be about funding energy projects. So today we are very excited to be joined by Andrew Rabbe and Greg Thompson from Central Maine Power. Rather than introducing them now, they'll share a bit about themselves and their work once we begin. But first, I want to just start by giving a quick overview of the structure of our workshop today. So usually the way our In Practice workshop series goes, we start with a presentation and then we follow up with time to ask questions and converse with each other and workshop projects that we have. But for these grid conversations, we've asked our presenters to address the questions, questions that we've given them in advance. And these are all the questions that we've heard from you. So rather than our usual format, today we're going to have more of a conversation or a discussion. So Andrew and Greg will address the questions that we've shared with them. And throughout the time we have together today, you'll be able to ask questions and discuss the topic that's being presented on. So it'll be more of a, asking questions, as slides are being shared as opposed to waiting to the end. To get the most out of this time, we're going to ask you to help us adhere to the workshop structure and this time frame. So after this intro, we'll move right into the grid conversation with Grid and Andrew, and we're hoping to spend about 65 minutes on that conversation. So again, it'll be like a discussion format with them presenting information based on questions we've asked, and then time for you all to ask questions. And then we will if there's any questions that arise that are like off topic, not related to what's being presented in the moment, we ask that you hold those either till it comes up later in the presentation or to the end, where hopefully we'll have time for like a 10-minute sort of general Q&A. So before we close out the meeting, we'll just present quickly about some other workshops that we have coming up in different opportunities. I would also just encourage you, because there's a lot of things going on right now with presentations, learning opportunities, funding opportunities, events that you are hosting. So I would encourage you to use the chat to share any of that information, because it would be great, while we're all together, for people to see what other things are going on, because there's just a lot of things we can take advantage of. So we just also want to ask that during this time that you abide by some simple guidelines, which is just staying on topic, because we could easily go down a lot of different roads here, and just we're working within a short time frame. So whatever's being discussed at that moment, it would be great if we all stay on topic, really try to share airtime, so we're not each dominating the airtime. And then again, hold anything that's off topic, any questions or comments that you have for the chat and or the Q&A that's at the end of the presentation or the discussion portion. So we're going to go today until 1:30, but if you need to hop off at 1 or before 1, please just leave any questions that you have that we haven't gotten to in the chat, and we will try to get to them before the workshop ends. And then this recording is going to be made available to you after, so you can follow up and see how we answered those questions. So before we close out, I just wanted to, there's a lot of people on the call, but I just wanted to see, does anyone have any questions on how this is going to go, or anything you wanted to just, clarify before we turn it over to Andrew and Greg? Just making sure we're all on the same page here. Okay, I don't see anything, so I am going to go off my share and turn it right over to Andrew and Greg so we can get going with our conversation. Thank you both so much.
Absolutely. Thank you for the invitation. This is great. And I will get to where I can share my screen here. Right. Let's see. I have it all set up here. Hold on. Okay, there we go. Hopefully everybody can see it.
Not yet. I'm not seeing it yet. There we go.
There it goes.
Perfect.
Perfect. Thank you.
So yeah, I want to thank everybody for the invite. This is great, and we appreciate being here and giving you our information from the grid. My name is Greg Thompson. I've been with Central Maine Power 20 years now, mostly in electric operations, safety, working with line crews, done a lot of storm restoration, and participated in conversations like this. So have a good working knowledge of the system and where we're trying to go. I'll let Andrew introduce himself.
My name is Andrew Rabbe. I'm a supervisor in the substation operations department. Majority of my work is in the greater Portland area, but I've worked in substations all throughout, primarily the midcoast up to the western mountain states. And I've worked storm restoration basically throughout the whole state, because when we go on storm, everybody shifts away from their regular job and we all have separate storm assignments. I've been with the company just about 3.5 years, but I've got, wow, 23 years in the electrical industry, whether it's utility or construction, upgrades, substation building, all facets of electrical construction. And when the opportunity was presented, Greg and I had talked and thought that it was a great thing to do, to get together with everybody and speak and give you our little piece of the grid and hopefully answer any questions you may have.
So one thing before we get started, you'll notice from our backgrounds, we're heavy in operations. We are hands-on. So when we talk to things, a lot of times we take what people want. When you're talking about electrification of the grid, there's a lot of things that you could add into that. We come at it from an also, what can we physically do? Because sometimes those are at odds with each other. So you may hear us kind of between us talking about, well, this would be really great, but there are some parameters that we have to live by. But essentially what we did was we took all of your questions that were presented to us. We've put the question out there. We'll recap what that is. And then we gave you some information on the slides, and we'll talk to those. Again, as Gabe mentioned, please feel free to ask questions. I know I can get talking, Andrew can get talking, and we can get kind of boring. So feel free to ask whatever you like. And we're going to kind of split some of the slides between us. But the first one was, what's meant by the grid? A brief grid 101 presentation would be helpful so attendees can have a better understanding of generation and transmission, distribution, et cetera. And I'm going to turn this right over to Andrew because it's right in his wheelhouse.
Okay. So basically there's the two general divisions of the electrical system. You could count three if you start getting into the generation portion of it. So the generators, that is your solar, your fossil fuel fired power plants. You have hydro. Those are the three main sources that we have here in the state of Maine. So the generators, they use energy, whether it's wind, hydro, solar, or burning of fossil fuels to spin an alternator, which creates the electricity. Then it goes out to the step-up transformer, which boosts the voltage so it can be sent a long distance. That's when you start getting into the transmission system. The transmission system in Maine, we have interties to New Hampshire. We have interties through Versant up to New Brunswick in Canada. So we are all connected to each other on our transmission system. Now, once you get off the transmission system, like our transmission system here primarily runs at 2 voltages, which is 345,000 volts. That's the main backbone that runs from basically all the way down the East Coast. We're all interconnected all the way up to New Brunswick, up in Canada. And then we also step it down to 115,000 volts. That's for shorter distances, substation to substation type of things to feed our distribution system. Now, our distribution system comes in usually at 115 or 34,000 volts, which is another one of our sub-transmission circuit voltages. And then it gets stepped down and then it goes out into the neighborhoods. You'll see the substations. If I'm going too fast, you could slow me down. Substations are all over the place. You could see, depending on where you are, they might be a single transformer with a single breaker and a single circuit going out, or, here in the city of Portland, we have an underground network system where there's 5 circuits and 4 transformers all tied together to feed the downtown Portland. So, we lose one circuit because of, equipment failure or something like that. Nothing happens. Everything else maintains its energization. But that's a network system. It's, there's only one in the state and it's in the city of Portland. After you get to the distribution system, then it goes, into the little transformer that's typically pole mounted, the little gray can on the pole outside your house or the little green box, and then it goes into your house. The simplified analogy, I actually like that one, the electrical grid to the road system, the transmission system. That's our turnpikes, highways, and then distribution system is our local streets, dead ends, things like that. So does anybody have any questions about the actual electric system? Because love to answer them.
All right, one thing that, Andrew mentioned it kind of at the beginning, there is a separation of supply and delivery. Central Maine Power, since deregulation, does not do any supply. We can talk to some of it at a high level, and some of it that we start to get into is generation as far as base generation, and then the renewable generation or cyclical generation. And the difference between the two, base generation would be like a gas-fired plant. It just runs all the time. You can turn it on and off, but generally, once you turn it on, it runs. Versus, say, a solar that starts when the sun comes up, peaks middle of the day, and then when the sun goes down, it stops generating or reduces its generating significantly. Really not important for a delivery company as far as what makes the electricity, because again, we don't control that in any way. What we do have to factor is whether it's base generation or whether it's cyclical, because your generation system has to match what your load is on your delivery system. So if those are out of sync, we have to make them in sync, either by increasing generation or reducing what we have for load on the delivery. So again, they are tied in a sense, but they also are separate as far as who controls what. The other thing is, as Andrew said, we are connected. We have open points, closed points that we can change direction on our transmission system very easily. It's built for two-way transfer of electricity. We can import from New Brunswick all the way through Maine and into the lower states, or we can reverse and we can come from Massachusetts, New York, if they have an abundance, and transmit up towards Canada. It really depends on what is needed, and that is controlled by a group called ISO New England. It's the independent system operator, and they control all of the delivery companies and generation across all the New England states. They're a nonprofit. You can look them up online. You can see what is actually making the electricity. Right now, it's about 50-60% natural gas and the rest renewables and a little bit of nuclear. But that is a great resource, especially on the generation side. So that's kind
also,
of our. Go ahead, Andrew.
I was going to say, and they also tie in with ISO New York and ISO. All of these different areas have different independent system operators, and they all work in conjunction with each other to make sure that the power goes where it's needed throughout basically all of North America at this point, with the exception, I think, of Texas is the only one that maintains their grid independence.
All right.
So, did see a couple questions come in.
All right.
Let me see here. From William Franks, does the large amount of solar being installed create short-term stability issues for CMP? There's certain, I can say yes and no. It depends on the developer. There's studies done with every piece of solar that comes onto the grid. The studies are reviewed by our engineers. They go how it's going to be intertied, how it's going to affect everything. Now, for the majority of the solar, like, we don't have a lot in Portland, primarily because of the price of land. So I know of 3 solar developers that have come online recently. 2 of them went great. We have no issues. We actually welcome the high load relief during the summer months. And there was one that had issues with their inverters that was making everybody's lights blink. But we were able to isolate that. They fixed their inverters and they've come back. Since then, they've come back online with no issues. You know, it's not an easy process, but it's manageable.
There are some challenges as you get enough of it, and that's more at the ISO New England level. Anecdotally, I talked to them, and Cape Cod was an area where they saw some issues. There are about, I can't remember, it was 100,000 or so solar panels that have been put on. And when you start talking that amount, and these are all rooftop units, so individual customers, when you start talking that amount, you start decreasing your load. And remember, I talked that your load has to match your generation. Well, they started decreasing the load on one of the natural gas generators. So they had to call quickly and say, you need to ramp down because you're going too high and that's causing an overvoltage situation. They did. Shortly after that, a thunderstorm came through. So they started losing generation, and they quickly have to call the generator, the natural gas generator, and say, you need to fire back up because we need to maintain to keep that load. So more on a larger scale, we haven't seen too much of that in Maine. It's an issue, but it's we'll talk as we're designing these, we're trying to work that into our plan. But from an ISO New England standpoint, it does mean that you have to have generators on standby that you may not have had in the past for peak times. So, Andrew, I see another one from Yvette. How many homes share a transformer? Not every pole has a transformer.
All depends on load. You have some homes that have EV charging and electric snow melt, and then right next to it you could have a double wide with solar and heat pumps. It all depends on the load that's forecast for each individual home. Like the National Electric Code basically gives you 8 watts per square foot. So if you do that calculation based on the home, you can anticipate how many kVA transformer you're going to need for that house. Now, like I have at my house in West Bath, we have our own transformer, but it's because we can't share with anybody else. It's too far, the voltage would drop to feed another house. But, you know, once you get into cities, say like Lewiston, Portland, Boothbay, anywhere where you could have a fair amount of municipal customers served by one transformer, that's where you're going to share transformer load. You know, if they start getting voltage issues, that's usually when they'll upsize the transformer or split the load. Or if your lights start to dim, they could call out a troubleshooter who's they work 24/7 around the clock, and they'll come out, they'll put what's called an amp probe, they'll wrap it around the line and see if we're getting towards the high end of that transformer. In which case, you know, they put in the work order or change out the transformer to get everything running again. There's no specific set on how many customers are fed from each transformer. It's more or less a case-by-case basis.
Perfect. I did see there's a question from Maxim. What level of the system are you most worried about in terms of vulnerability to natural disaster damage? We're going to start going into that portion, so we'll kind of answer that question as we go along and what we see. So with that, we will start for what is the current state of the grid in terms of frequency and duration of power outages? What are the most common natural causes of power outages, and how does climate change impact the likelihood of the power outages? Andrew, I'll let you start again.
The current state of the grid is getting kind of a facelift, I would say. You know, Greg's tenure here is longer than mine. But since I've been here, I mean, since day one, aging infrastructure is being changed out. There's a lot of money being spent to modernize the grid, to bring stronger poles, bring in more equipment to help sectionalize outages, which means if you have 1,000 customers on a circuit, they have devices in there, electrical pole mounted devices or underground mounted devices to sectionalize. So if there's a fault down at the end, you're only taking out, say, half that circuit instead of the whole thing. The Safety Katie Sadie, those are numbers that we report on daily. Every day we have a call at 8:30 in the morning. There is, you can read what each thing is, and we have metrics that we have to follow that are set by the PUC. These are our minimums, and I'd say over the last 2 years for sure, we've exceeded these metrics by the changes that we've been making to the grid. And which is, upgrading wire sizes, upgrading poles, putting in automation devices, upgrading substations. You may not see everything that we're doing, but I can tell you, as boots on the ground, we are flat out. We run 24/7, improving the system every day. I don't know if you want to, does everybody understand the Safety Katie Sadie? We safe to move on with those targets?
I thought I'd cover it real quick.
Sure.
So that's kind of what we're doing right now. However, we put in a rate request that gives us money back through rates for these improvements. And in return, we are measured on these regulatory targets. So I'll touch on them briefly. Safety, that's basically how many times a customer is averages these numbers. So for example, 1.89, we rounded up. Basically each customer, the average target is 2 outages per year. Okay. Now, not everybody has 2. Some have 0, some have more, but that is the average by the PUC. And our goal is to be less than that 1.89. We just did out our reliability targets. We have not finalized them for 2023, but we're somewhere around the 1.81 target, metric. So we're doing okay with that. We still want to get that down, and the goal is every year we do try to push that down some. But that's that goal. The Katie is the duration. So when somebody has an outage, how long will that last? So basically, this target is 2 hours per outage. Now, there's a lot that goes into that number. Andrew kind of walked you through it real quick, where we have to get the call from the customer, then we have to dispatch the truck has to get there, determine what's wrong, and then make the repairs. Again, this is an average. Some may take a long time, others, we may be just around the corner and it takes a few minutes. Our average is 2 hours. Right now, and Andrew, help me, I believe we were right around 1.75.
Yeah, we're doing pretty well on the Katie numbers.
And again, I mean, that goes to how resilient can you be when you experience a failure. And then lastly, Sadie is kind of a combination of the two based on how much time when customers are interrupted. It's kind of a weird combination, but essentially it's hours, so it's about 4 hours. Now, where that comes from is when you start talking about your longer term outages, car pole accidents, that kind of thing, that's what kind of drives that number up. But really, Safety and Katie, we're doing quite well on. And if you're doing well on Safety and Katie as utility, typically you're doing well on Sadie. Again, always trying to move those numbers down. And when we go into talking about planning, one of our objectives is when we plan, our goal is to try to affect these in a downward position, because it all means less outages and less time without power for the customer. Questions on any of our regulatory targets?
We had a couple.
Yep.
So I think you answered this question. The Katie number is in hours.
That's an hour.
And yeah, and there was a question, I think you also answered this just indirectly, but when you say you've exceeded targets, does that mean worse or better? But I think you're saying it's better than what you're
Yes.
what you
We're
were
better than what
predicting, yeah.
we're mandated right now. Yes.
Yeah. And then we have a question from Jay in the chat, which is, I've assumed you know a CMP no at CMP power is out rather than the customer calling in an outage beyond a single home or building. Let me see if I can read that again. I've assumed you know at CMP power. Oh, I assumed that you know at CMP power is out other than the customer calling in an outage. Yes. So you don't, customer calling isn't the only way you know there's a power outage.
No, so if you remember back 2015 or so, we started putting in AMI, advanced or automated metering infrastructure. Those meters, smart meters, will tell us when they lose power. And at that point, there have been times where we've had outages at 2 o'clock in the morning where not one person has called us, but so many meters go out to meet the algorithm to say you've lost this device or this device is open. We send the truck goes out, makes repairs. People have power back before they even called in. So yes, we have a number of ways that we learn that there are outages. Andrew was talking about some of the work we do that may not be seen. We've automated a lot of our devices, and those devices will tell our operators that are on 24/7 that the device is open. And beyond that, it'll tell us other information. What else can we get from it, Andrew?
You can get the real-time loading data. You can get the fault sensing, fault magnitude. That's kind of when I say fault magnitude, like I can tell by what I get on certain devices if it's a tree that came down or a car that cleared out a pole based on the event magnitude. Like if I have in a three-phase system, you have A, B, and C. If I have a straight fault across A, B, C, I know that something big happened. Whereas if I just have a C to ground fault or something like that, it's probably a squirrel, a twig, a branch, or something smaller. So we're not there all the way with that yet. The primary area that they've started installing those smart automated devices is in the Alfred Service Center, which is mostly all of York County. They've put up over 100 devices so far, and I think they're doing another 100 this year.
Mm-hmm.
So that's where we actually started independently tracking the Safety Katie and Sadie numbers for Alfred to see what type of improvements are garnered by doing this automation of the grid as we expand elsewhere. The plan is to automate everything over the next, I believe it's 5 years, Greg?
Yes. Yep. It's basically adding an additional 3,000 devices.
Yeah. I don't know. Sometimes I don't know the overall plan because I'm the guy out there. So.
So one thing too, I want to mention about our targets before I leave them. These do exclude certain events, which is frustrating for customers. We have devices out there called reclosers that cause momentary outages. And think of this: when you leave and you come home and your clocks are blinking, your power may not have been out, but it blinked out because a tree came down and touched the line, and then it cleared and the power came immediately back on within seconds. Those don't count, but they're still outages. We still track those and we still manage those. Large storms. There's a whole calculation that you do through EEI that tells you when you can count a storm versus not count a storm. Some of those storms in size are excluded. If you think about the Grinch storm during Christmas, that was such a large scale that they don't add into the numbers because it would skew it very heavily one way or the other. So this is really looking at a system average. And when you're looking at those outages, this is where our biggest outages or where the most outages occur from. You'll see tree out of the right of way is one of the big ones. If you think out of the right of way, we have a right of way that we are allowed to maintain that is 8 feet either side of the pole and 15 feet above. That is it. That is our window. It sounds like a lot. It's not. And there are restrictions that homeowners can put on that, you know. So it's a challenge. One of the things that we did, if you watched our case with the PUC last year, we've asked for a little bit of a change in our trim philosophy. We're looking at going from 5 years to 6 years. Currently, right now, we trim all of our circuits every 5 years. They're on a cycle. However, what we found is that because of this tree out of the right of way, the 5 years is actually very good, and we feel we can drop that to 6 and not jeopardize our reliability. But we can use some of that money on that 5th year to look at our 3-phase system and how can we remove some of the canopy. So that 15 feet above, go what we call ground to sky, so that you don't have those limbs, as Andrew said, dropping down and taking out all 3 phases. Again, trying to minimize the impact and reduce that Cadian safety number. Again, unknown is a big one. I can tell you that having been out in the field, a lot of the unknown is likely animal or tree. The reason I say that is you see unknowns increase a lot in the wintertime. The tree comes down, causes the outage, falls off, but it's in the middle of the snow. And we don't have the line workers get out and dig for it. Same thing with an animal or a squirrel. So a lot of those are in those other categories, but animal is a big one. And we've done a number of different things. We have installed animal guards. So when you look at our transformers at the top, we have plastic pieces that go in. Unfortunately, squirrels, other animals, very curious, and they try to open those things, and that causes problems. In addition, they will chew on various parts and pieces. Lot of times the wire. So we've gone to a different coating on the wire, stronger coating on the wire. And lastly, one of the ways that you can deal with this is when a transformer goes out, it takes the whole line out. Unless you have a cutout or a protector device on that single transformer. So that's another thing we've done to limit that outage to just that transformer and not everybody's transformer. So again, all ways of looking at how can we reduce the number. I won't go through the others, but any questions on those? Anything else you wanted to say, Andrew, on that?
No, I think that's it. I definitely agree with the unknown. You know, it's almost always animal or tree. Almost always.
And again, just pictures of some of the outage. Again, we talked tree out of the right of way. This isn't the little tree that's growing up into the line. These are big ones that come down and impact our line. So again, what is CMP doing to increase the resilience of the grid? And again, I'm going to let Andrew start on this one.
So basically what we have here is we have some pictures of some automated devices. Right here in the picture to the left, that is called a 3-phase recloser. Now, I can tell by the little cord on the bottom that this is something that's controlled remotely and by the antenna on top. So what this is you have your 3-phase that comes out from the substation, and that's kind of our backbone. Off of that 3-phase is all, you know, feeds for residential streets and customers, 3-phase customers, things like that. So what this does is right now your station circuit breaker will go 3 shots to lock out, they call it. So If it senses a fault, it's going to open quickly, and then it's going to try and close back in, hoping that whatever it is, if it's a small tree branch, that close back in will either burn it off or it'll pop off the line with that close back in. Because what you're doing is you're exciting a ton of electrons in the line when you're doing that. And it'll do that 3 times. If it can't clear it, then it opens up and it goes to what's called lockout. This device on the left here is the same thing down the line. So the goal is to have these, I think eventually every 500 customers is to have a device like this on the 3-phase backbone. So what it's going to be is, instead of the station breaker opening and going to lockout for something all the way at the end of the line, every 500 customers, you're going to have one of these devices in there. So what this is going to do is you'll be able to sectionalize just a block of 500 stay. Instead of losing 1,500 customers, you're only going to lose 500, close in from one side. Hopefully you have a tie you can close in from the other side and just isolate the outage. This is a Viper style switch. So it is controlled via SCADA, which means that I can call up or Greg can call up and we can have them open this in case of an emergency. If the fire department, you don't need a line crew or anybody there to open this. This can be opened 100% remotely. Now, once you get over to any question on reclosers, because we have these for single phase as well, which is just the one wire at the top all the way down your road. That's single phase. This is 3-phase, which is more or less your backbone. If anybody has any questions, please feel free to stop me. So then we're moving, if you go to the top 2 pictures, we're moving to larger poles. Now, if you see the diameter difference between the one that says AG on it and the one to the top right, I can't see Greg, but I think that looks like a class 2 versus a class 5.
It's actually a class 2. It's the top of the class 2.
Oh, okay. Well, the top of the class 2 is basically the base of a class 5
Yes.
for the most part. So the older poles were class 5. If you look at the top to the right of the AG, that is about the approximate diameter of the old poles that were installed many years ago. This is the base of the new pole that says AG on it. That is a class 2 45-foot pole. Electrical systems used to be installed with a class 5, which is that skinny 35-foot pole as all your backbone. Now you're getting a much larger, stronger, sturdier pole in the ground, which is going to help with, when trees come down, they're a lot less likely to break the poles. Now, it does make car poles a little more interesting because instead of hitting a smaller pole, you're hitting something bigger. But it has a lot less likelihood that it's going to move. Now, we're installing these poles. My office in Portland looks out at what we call the pole brow, where they stock these. And we probably go through 8 to 10 truckloads, which there's 50 on each truckload every single day, upgrading poles. Now, a lot come out of Portland to service other areas. So it's not specifically the Portland area. So they're going all over the place. Now, another thing that the company's been doing is something called tree wire, which is a coated conductor up in the air. The original wire was either a copper or aluminum wire, and it was bare. So if you have a branch or something, the wire that's right underneath the 3 wires on top is your system neutral. So if you had a tree branch come down across a bare conductor and contact that bare conductor up top with the system neutral, it would short it out, and that would cause a fault. That would cause either your lights to blink or the circuit to go out. With the tree wire, that won't happen. For the most part, sometimes the trees will just sit there. They'll just rest on the tree wire. At that point, hopefully we see it on a patrol or somebody notifies us, because we're not going to know it's there. Now, on the right there, I can't really see the picture too well. That looks like
That's bare
exposed
conductor.
conductors. And
Just bare conductor versus
that's
the
just bare
versus the
conductor.
wire.
Another thing I will say is that all these cross arms, which are the wooden pieces where the lines, you got a dead end structure right there, and just looks like a double arm. Everything we're installing now is fiberglass, no more wood, because it doesn't rot. Anything you see going in, you're going to see a bigger, stronger pole and a fiberglass cross arm, because that's another cause of outages is cross arm failure. Greg, do you want to go into a little bit about some of the issues with tree wire, other than, things can just sit on it?
So we're going to go into it when we talk about this. What role can communities play in increasing
There we go.
resilience? There's a couple things to understand. First of all, when you talk resilience, a lot of people will tell me, well, that means we're not going to have any outages. Anybody who tells you that they can prevent any outage is lying. I know that's a harsh statement, but it's a big, big challenge. There are going to be outages. What it does mean, resiliency, is that they're less impactful, so less outages. So when we talk about all those devices we're putting in the 500 mark, we're talking about ways those devices can talk to each other so that they limit the size of the outage. We're also talking about where we have a redundant system, maybe a nearby circuit. We can feed from that circuit automatically and try to self-heal around the area that's out. So again, it's how can we reduce the number of outages, and when we have an event, make it quicker to restore. So as Andrew said, we put up the fiberglass crossarm. The wire still may break, but it takes a lot less time for a line crew and less resources to put the wire back together than it does to replace the crossarm. So you're becoming more resilient in that need. Now, when you talk about this resiliency and you talk about tree wire, you talk about all these reclosers, you now have to start talking about the rest of the infrastructure. So now you're talking more poles, bigger poles. Again, going to that class 5. In the old days, we could run a smaller wire without any tree wire coating on it, plastic coating, at probably 250-foot spans. Because of the tree wire and the weight, we might have to do 150-foot spans. So now you've added poles along the side of the road, which again is a give and a take. So a lot of times when we're doing this, and we'll talk about the planning, we're looking at what could this need? What could this area benefit from, rather than just a broad brush, we're just going to do this one thing. And again, tree wire has its own possibilities. The system is not going to operate the same. If a bare wire goes out and it touches that neutral, it touches the ground, there's a high likelihood, as Andrew said, it's going to kick off the sensitive devices within that transformer or that recloser and open it up. Tree wire does not do that. It's got a coating on it so that it doesn't do that, which means your first responders can show up and things are still on their jobs. So we're working through, and we have a safety program that works with them to discuss that, because that's a serious issue for them. In addition, dynamic switching. I talked about we may have an adjacent circuit, and that adjacent circuit we can tie to automatically. A lot of times when we get out with first responders, and I am one, I love them. They're an absolute must-have. Please support them. But they start learning what the feeds are. Well, that feed today, due to dynamic switching in the future, may not be the same. So when the power used to come from the north, it now comes from the south. So it's not de-energized like you thought. So again, we're trying to work through a lot of those issues, because again, it does change. The CMP have a plan with outreach to get customers to use less electricity. We do. There are a number of reasons that that's good for the customer, obviously rates and whatnot, but we do have things like how to conserve and that kind of thing. What we find is with the electrification of vehicles, cell phones, heat pumps, it almost fights against it. As much as you conserve, you start to use as much. So the CMP planning to bolster their maintenance clearing of branches in conjunction with tree wire, or at least in the interim as you update the line. So again, we trim every 5 years. The biggest challenge we have is those trees out of the right of way. That really the tree out of the right of way, due to the size, is not as much an issue with tree wire because it will hold the tree, which creates a dangerous problem. So I'm going to move on to the next one. What is CMP doing to increase the capacity of the electrical grid? And I'm going to talk about this in 2 ways, and I'm going to also bring in a little bit of the resiliency to it. We talked about the transmission versus the distribution. When you're talking the transmission system, the 345,000 bulk transmission system, we have more than enough capacity. About 15 years ago, again, we did a major upgrade called the Maine Power Reliability Program. It built another second backbone to what was existing, and we upgraded the existing line. Maine is fortunate. We use approximately a third of what's on that line. So we have more than enough capacity. As Maine increases, it's what we can export. So other areas, New York, that's why we're all tied together. They may have to pull from someplace else. So again, there's enough capacity on our system for Maine without question. When you start getting into the distribution, it's less about capacity and more about ability. You start looking at two-way power flow. And, you know, the system was designed 100 years ago when you only had one flow. It came from the generator through the substation to your house. Now, in amongst that, we've got distribution we put on, or distribution generation, which we've put on in the middle. So now I got to be able to have power go through that recloser both ways and not trip them off. So when you talk about reliability, again, the transmission system, much greater distances for trim. Already we use steel poles, we use steel structures to hold our utilities up. Again, because of some of the concerns with self-supporting structures and whatnot, on the distribution, we've been slower to get there. We're starting to migrate that way, but we have to do it in a cautious manner. And so what you start looking at are these factors. When you're going to start changing the system, you look at reliability, load growth, utility scale interconnections, distribution connections, natural resources, aging infrastructure, and the beneficial electrification, so that you can put together a better plan and try to hit all of those needs at once, which is a challenge. And again, this is another way that we look at it. You know, we look at it from a 10-year system. When you boil it down, our base growth has not changed significantly over the last 100 years. What it's used for has changed. And yes, we've had to adapt, but we've been able to keep up with that based on our look ahead. But we take into account all these different factors. So your resiliency analysis, that's that storm safety and SAIDI. The reliability analysis, again, that's our general everyday. We don't want to make things worse. We want to make them better. Again, new customer load or generation system impact study. We talk about grid modernization for resiliency. That's that self-healing protection. We add in a connection to another circuit so that we can try to reduce the number of outages. One thing we've done new, and it's helped a lot of development for communities, it's helped developers of solar and other groups, hosting capacity maps. It's right on our website, cmpco.com. And if you go into the search bar and type hosting maps, you can actually go in there and see where there's already capacity, where very little upgrades are needed, if any, to be able to host something of any size. It'll also tell you where there might be less capacity and it needs to be upgraded. And again, we're working on those through this planning, but if somebody wants to do that earlier, we can certainly make that happen. And then cluster studies, we do that through ISO, because again, we have to make sure that what we're doing doesn't impact what they do on their end.
Greg, we had a little comment in the chat. I've heard concerns that the grid can't handle adding more charging station for electric buses at school districts. It sounds like what you just said disputes that, but I'm curious what your response to that would be.
We're going to talk about that right here. Again, what is the local community's understanding of how electrification will increase strain on the grid? So the grid continues to grow, and it grows based on the needs of society. Okay. If you think about it, a long time ago, people said, oh, there's going to be so many computers, so many electronics, the grid's not going to handle. Well, the grid handles it. Industry. We said we're growing industry so fast, the grid's got to keep up, and it did keep up. We know there's new technological advances like heat pumps, electric vehicles, distribution generation that we haven't even thought of. Here's the balance. Right now, again, we can hold a 10-year growth pattern on all of our circuits. The challenge is, how much do you build out and how much capacity do you build in, understanding that there's a cost to that, both to the company and to the ratepayer. And so it's this balance, right? I could say, I want to change this and I want to go to a 30-year capacity. What's that going to do to cost? Another way to look at this, especially when you're talking about distributed generation, the natural growth prior to any legislation in 2019 with net energy billing and whatnot, we had about 49 projects a year. After 2018-19, we went up to 650 a year. When you have that kind of growth, there isn't any industry, if that growth happens, that they can handle it without a change. We've handled it, but there is a change and it's a cost up front. There's a lot that goes into what that cost could even be and how we get there. But the fact of the matter is, anytime you push something that far, there is a challenge, and we're just working through that challenge. And I can't remember, we've hooked up over 200 of these projects, and we're now over, I believe, 100 megawatts, Andrew, on solar right now.
Correct.
So again, when I say there's capacity based on the growth. If things change significantly, we have to change and we have to step up and we have to be there. Hopefully that answered the question. Now that's what we had prepared. I'm willing to go off script. I know somebody wants to see the hosting capacity maps, but if somebody has other questions, we can certainly try to answer those.
We did have another one that was based more on the grid structure conversation. It said when homeowners get solar and a new transformer is needed, who's on the hook for that when they serve more than one home?
Sure. We are obligated to be able to serve based on our single phase. Okay. And basically what that means is that change is already into the rates. So if there is a change like that, somebody goes from and they need a 10 kVA to a 25 kVA. That's already part of rates. We put that up. There's no cost individually to anybody. So when we're doing a lot of them, there is that cost is socialized in a sense. Three-phase, because of size and cost, that is a different structure. And there usually is a cost-sharing component.
Like we have another question. How are you preparing to accelerate the number of projects per year for distributed generations, since this seems to be growing very quickly?
I see you smiling, Andrew. You want to start?
Well, I was just going to say we have a lot of people on board. We've been hiring people. There's subcontractors, subcontracting engineering firms. I believe on the books right now, there's 700 DG projects slated to come online. So with 700 projects, and that's projected, I believe, over the next 3 years. So if you do the math, that's basically one per working day for 3 years. Now, it doesn't mean they're all going to go one per working day. There may be days where there's 10 of them that come online. But it's been a challenge because my group is directly involved with working on DG projects, installing voltage regulation on the distribution circuits and capacitor banks to control the VARs and reactive power. It's every single case is reviewed by engineers, and we get recommendations on a case-by-case basis. So the preparing is a swift and very well thought out response based on every single DG customer.
So to jump off of that, when you had 49 a year, you had one department, 2 people that were essentially managing. And it was a pretty streamlined process, if you will. When you get 600, and the legislature breaks it up into tiers, you need a team. And we have a team of engineers, project managers, groups that do capacity studies, that is well into 60 or 70 people, besides the outside contractors that we bring in to help do these. Now, that's how we've prepared. A lot of these systems, when you get a number of them, again, ISO New England has to be involved, and that's not our process, that's their process. Because again, they have to manage that balance between generation and delivery. So a lot of these, we hear about projects getting stalled and whatnot. It's not so much on the CMP end as much as we're waiting for a cluster study from ISO New England. And we can't dictate to them how they ramp up. They have ramped up, but again, it's got to get to us first, then they ramp up. Now that they've ramped up, now what you're seeing, and Andrew kind of alluded to it, we're ramping up on the construction side. And now we have the PMs in place, we have the contracts in place, we have the contractors in place to be able to make that happen. Oh, I see somebody asked a question about billing from solar farms, and it's very complicated and confusing. I can explain it very briefly. Until recently, it was a very manual process. Basically, it takes information from the solar developer has to get us information on who is signed up at what rate and who they're sharing it and what the credit structure is. And essentially, they drive that process. I could spend a whole another hour on and get somebody else that's much more qualified to talk about that billing structure than me, but it is very, very challenging because it is not an apples to apples onto how we bill through our other rate structures.
I did want to I think we answered this question, but I just want to make sure, what level of the system are you most worried about in terms of vulnerability to natural disaster damage? And it sounds like it's like lines and poles from what you're saying. Is that correct?
Vulnerability, really the distribution system. Go ahead, Andrew.
Yeah, I was going to say the vulnerability is 100% the distribution system. The transmission system, even in the storms that we've recently had, obviously everybody experienced the same storm we did on December 17th up until Christmas Eve. The transmission system, the 345 and 115, was hardly impacted by that at all. It ran the whole time with very few operations. The distribution system, on the other hand, took quite a beating with the amount of trees and wind and flooding. We lost a couple substations due to flooding, mostly in the rivers and things like that. Hydro adjacent substations was the primary damage during that event. It's definitely the distribution system, though. It's the wooden wires of our business, as we call it, which is basically from the substation out.
And I see the question, why aren't we looking at putting lines underground? And I'll be honest, the last few storms have really highlighted just one of the problems with going underground. And I certainly want to start by saying we are not against underground at all. We have a number of underground facilities that we maintain, both the network down in Portland as kind of a little network in Lewiston, and then we have a lot of areas that have put in underground for private communities or cul-de-sacs, however you want to call it. But to do wide scale underground, you start looking at, for lack of a better term, drainage. I've seen a number of these that were put in, and all of a sudden you're chasing a underground transformer down a stream because it just left. And it's much harder to build. Once that happens, you have to get the road repaired, then you have to be able to put in the ductwork, then you have to be able to put in the wires, and then put your transformers back. And so, that's just one of the concerns. Another concern is Maine is largely made of rock, and you have to start blasting, and you have to start putting a lot of infrastructure in for underground. Lastly, it is a challenge to restore. When it goes bad, it's not as quick as sending the line crew out and having 2 or 4 guys go out and put wire back together or even put a pole in the ground. You're usually talking 6 to 8 people to go in and either pull out old wire or bring in new, or if you can, dig with an excavator down and splice the wire, which is a very technical process. So it does cause time and challenge. And again, there's a cost component to it. Again, when roads are being redone, we always look at it. We're always asked, can we go underground? The answer is yes. Challenges include who's going to pay, how are they going to pay, and not so much the installation. A lot of times we can work about that, but who's going to do the excavating? Because we're really not an excavating company. We don't have the blasters. We don't have the excavation equipment. We can get it, but again, there's a cost to that.
And also, just one thing, primary electrical wire has to be at least 36 inches down. So, you could have a roadbed. They're not going to dig 36 inches down. They didn't even do it for 295. Once you get to 36 inches down in a lot of spots, you're in solid rock.
Yep.
It's definitely challenging here. I can tell you that. You go to other places, especially in the Southwest where it's all sand, everything's underground because you're digging in sand. It's a piece of cake. It's definitely a challenge here with the amount of bedrock, and especially, and it's granite. It doesn't move very easily. I see another question. Is excess electricity that is generated with private or community solar systems and not used by the owner donated to the general public or low-income residents?
What I can tell you about that is, again, we don't generate it, so we have no control over what they do with it. I am not aware of any, but certainly it's a possibility. I do know that they do There are some of these that actually go out onto the grid and they do bid into the standard offered price. I don't know that of any that have been selected. But again, that's not something we could even really begin to understand because it would be up to them to put that in. So I see the question about the hosting map and looking at it, and I see less than a half a MVA, but I don't understand. So essentially what that hosting map is, it tells you what's available. So if you're looking at a three-phase charging system, you have to look at what the system is going to draw. Likely, if you're only doing one or two, you might be under that half MVA. If you're looking at 3 to 6 three-phase fast chargers, you may be looking at 2 to 3 MVA. Now, that hosting map is really a guide to say what's available. There could be some very cheap things that we could do, line upgrading, pole upgrading, that could be done to increase that and get up to that level. There may also be more expensive things we have to do. We may have to upsize the transformer at the substation because it's just not ready for that load based on the 10-year projection, or we have a project in the works and we have to push another project to move that project up. It all kind of depends. This just is a way to give developers a spot to look and say, where might there be constraints, where aren't there constraints, and how big is that restraint? Hopefully that helps. Again, it can't tell you exactly. It can tell you where there is capacity and what that capacity is. It all comes down to what is the service required. Again, if some of these fast chargers, if you're only putting in one, you're probably not drawing that half megawatt. But if you're putting in more than that, possibly you might be running into some problems.
Any other questions that folks have that they want to put out there? And feel free to, raise your hand, raise your virtual hand, either one, or just come off mute. Oh, we have another one. Yep.
I know we talk about wind or solar as the distributed generation. That's just because there's been such a big push on it. But it's really the exact same for wind power. There really isn't any difference. The study is the same. A lot of the wind powers right now are transmission level. So they interconnect directly on the transmission, which, as I said, is already a bidirectional flow. So a lot of times it's the cost to build the site and the cost to build the interconnection, which is just more expensive because building transmission line is more expensive. But it's really the same analysis and same process. And similar for battery as well. We've hooked on small battery storage options, and we have one of the largest ones in the country, I think, being worked on in the Gorham area.
Yep, that's mine. I was in a meeting about it this morning.
Yep, and again, we're working on readying the grid for that. Would you still be able to handle much larger wind generation from offshore turbines? Again, it all depends on what they're putting on and what we can put onto the system. It's easy to say we can handle it, but again, we have to have the load to meet that need. Hope that kind of helps. What upgrades are necessary to ready the grid for 3 gigawatts of floating offshore wind? All depends on where it's going to come on, quite honestly.
Yeah,
Go ahead, Andrew.
I was going to say 3 gigs of floating offshore wind. It all depends on where it's going to land. I've heard countless hypotheses on where they plan on putting this, and not sure where they could actually bring in that much power. And plus, that's going to need a conversion station and everything else. So you're going to have some loss there.
The other challenge is, and I mean, we've seen it with our own project, the New England Clean Energy Connect, as well as, we're seeing it with the northern group from the windmills down into our system. There's a lot of angst about putting transmission towers out in the rural parts of Maine. And I'm not saying one way or the other, but it's a concern. And, as part of putting this onto the grid, one of the upgrades may need to be to have more poles and wires. And that may be in conflict with what others think for the state. So it is kind of a challenge. And one that we try to at CMP work with customers on. I know there's been media reports that we don't, but we really do try to work with customers. Whose role is it to address where floating offshore wind will interconnect? Seems like a chicken or eggs problem. It really falls on the developer. They have to get all those permissions. They have to come up with their easements and where they're going to land their cables, where they're going to route their cables. They have to get permitting to say, here's where we're going to put them along the seabed. And, then once they decide that, they approach the utility and say, okay, here's where we're coming on. How can we get to connect? And then we have to find a route. But again, I mean, it really starts with the developer coming up with that plan, and here's how I'm going to connect.
Other questions that folks have? You can put them in the chat, or you can just come off of mute, or you can raise your hand and we'll call on you. I might not be able to see your hand, so if you're able to raise your virtual hand, that'd be great. And if not, that's fine too. Welcoming, appreciate all these further questions. So, why don't I go ahead and share some information? I'll do a screen share and just share a little bit about our upcoming workshops, and then we'll recheck the chat and see if there's any follow-up questions. So just so folks are aware, we know that there are a lot of great funding opportunities. Seems like all the time, but especially right now, I'm guessing most communities are feeling somewhat inundated. But just know that we R1CC and your regional planning organizations are here to assist you. So R1CC is doing some office hours where folks can just pop in on our Zoom. You can always set up a one-on-one conversation, phone, Zoom. We do also make site visits when you need us to. So we have been doing them 1 to 2 p.m. So that's our regular schedule on Tuesdays, and we'll run them through March 26th. Today, because of this conversation, we'll do 2 to 3 p.m. And I'll make sure we drop a link to that in the chat before we leave the conversation. And then I mentioned our other grid conversations. So next Tuesday on the 30th, we'll have the Governor's Energy Office answering some grid questions for us as well. So in a similar format. And then we're hoping to do our funding energy projects workshop in February. And if we don't get to it in February, we'll certainly bring it to you in March. And then if folks were able to attend our climate change and drinking water part 1 workshop last Thursday, that was in partnership with Casco Bay Estuary Partners and New England Environmental Finance Center as part of the Casco Bay Coastal Academy. We are presenting part 2 of that workshop. The first one was focused on community challenges around drinking water, mostly around like impacts from climate change, also a bit about capacity. the next one will focus on some solutions, so funding and how people are addressing some of the challenges. And that will be a February 22nd. More information about that and registration will be coming out very soon. So I will go off of my screen share. Oh, at first I just wanted to just put up for folks you're in Region 1, you know, who you can contact for your regional coordinator. We have Karina at SMPDC, Sarah at Cumberland County. You can contact Emily Rabbe at Lincoln County Regional Planning Commission. And for folks in Saginaw and Knox, I can be reached as your regional coordinator. So I'll make sure to put my link in the chat, my email link in the chat as well. So let's just go back. Whoops, sorry, we can see my chat there. I'll go off my screen share and we'll just look and see what other questions we have. Looks like there's one more question, which you may have answered from Yvette, but I'll put it out there. Are there going to be more employees hired to move the number of projects along faster? And I think you did address that, but I'll put it back out there.
Yeah, I mean, I don't ever remember us having the size distributed generation and projects group that we've ever had. You know, between the two, we're at 60, 70 employees, and then contractors under them as well. And then again, now where we are is looking at that infrastructure piece and how do we maintain that? And, you know, along with our regular attrition, retirements and whatnot, we're adding positions. We've added line workers, we've added transmission workers, substation workers. In fact, Andrew and I are on another initiative to work with college and vocational school kids to get them interested to come into this line of work. So yeah, I mean, you're seeing us move. And again, it's always that balance of what do we need versus cost so that we can keep our costs reasonable, but have the resources that we need. And I think the challenges right now with the studies, the holdup is not as much on our end as it is at other people's ends. So we're trying to help push them along as well. So.
Great. Well, if folks have no more questions, so it seems like we might be getting to the end of things. The last thing I wanted to do was just put a link into the chat if folks wanted to register for our next grid conversation. So I just put the Zoom registration link into the chat for our grid conversation with the Governor's Energy Office. So anything else before we close out from folks who are remaining here with us this afternoon, or from Greg or Andrew, anything else you wanted to add before we close out?
Certainly appreciate the time and the questions.
Yeah.
Really appreciate being able to do this.
Thanks for having us.
Yeah, we're very grateful to you too as well. We sent you all of those questions and you provided us with some very thorough answers. And just to let folks know, I stated this at the beginning, but I'll say it again. This is being recorded. We will collect all of the questions and resources that have been shared today, as well as the slide deck, and the recording of the presentation will be sent to you in a resources sheet. So you'll have all the information as follow-up, and certainly you can connect with us if you have additional questions or things you're sort of working on and would like some answers as well. So yeah, thanks again, everyone. Thanks again, Andrew and Greg. And we appreciate all of your work on this, and communities, thank you for joining us today.
Thank you.
Thank you.